And howdy. Welcome to the 2021 version of the Galaxy Code Architecture Talks. It's a series of videos covering these Galaxy Code Architecture slides that are available on the training network. To jump straight to the slides, you can go to bit.ly/gx-arc-slides. Yeah, and that will give you to the latest version of this. So as you can imagine, the code architecture of Galaxy changes quite a bit, so these slides need to be updated frequently, hence doing a new version of this talk for this year. Yeah, so let's start here. We have a Gitter channel, Galaxy Project/lobby on Gitter. It's a common way people communicate with the project. You can also find us on GitHub. A lot of projects underneath the Galaxy Project organization, and of course Twitter. If you're going to tweet about Galaxy, please use the use Galaxy hashtag, or just follow us on Galaxy Project. So for the first of these 8 or 9 talks, I'm going to talk about the projects on GitHub, and so this is what I call the architecture of the ecosystem. And I had that previous slide there to point out that and I use that slide a lot with the Gitter channel and such. But there's actually not just one Gitter channel for Galaxy. There's a lot of Gitter channels, and here's a list of a few, and there's a lot more. So it's a big project, and there's a lot of different facets. So you probably, maybe you're a tool developer and you don't care about how to deploy Galaxy. Maybe you deploy Galaxy and you don't care about Kubernetes because you use Slurm. Or maybe you're a scientist and you don't care about any of that, but you want to build some training materials around a workflow that you're interested in. So there's a lot of different, and the set of Gitter channels you follow might be different based on that. So I'm going to just talk about a variety of them as we sort of go through these slides. Obviously the starting off point, the launching point is Galaxy Project/lobby. For discussion around the code itself, the main core project's code base and development processes, Galaxy Project/dev is a fairly common and popular channel. I try to keep code stuff there. If you're an admin to Galaxy, this is an invaluable resource. A lot of admins hang out there. If you're interested in the cloud products, Kubernetes, these sorts of things, and how to deploy Galaxy there, or how to use some of our cloud offerings, Federated Galaxy is a great channel, dedicated group of people working on that. BioBlend is, we'll talk about more. We'll talk about more BioBlend and Ephemeris as we go. The EU server has its own channel. We'll talk about IUC and Docker. Talk about the training network and a couple of these other ones. This year we also introduced this concept of Galaxy working groups, and each of them has their own communication structure. Excuse me, and the Gitter chat channels are available from that link. So as we sort of go through these different projects in the ecosystem, I've broken into 3 big categories: user-facing applications. Applications are projects for plugin developers, and then applications are projects for admins. The main project, Galaxy Project/Galaxy, this is the core application, right? So the other talks in this series will really dig into the architecture of this. Right now, I'll just sort of briefly mention it and sort of say this is the main application. This is the web interface, the database models, the job running components that make up Galaxy. And it includes a couple other web applications such as the Galaxy Toolshed. But we'll come back and talk a lot more about this. But first, let's just, we're going to go through a bunch of other projects in the ecosystem where we're not going to talk about the code architecture in detail, but we're going to let you know that it's there, how to communicate with it, the language, and what the purpose is. So Cloud Launch is a Python application based on Django, and it drives launch.usegalaxy.org. So this is a site for launching Galaxy VMs and other VMs. They're called appliances on cloud resources. So check out this project if you're interested. Yeah, as I mentioned, it's a Django app. Probably the Gitter channel here if you're interested in this, is the Federated Galaxy channel. Presumably, if you found this talk, you know what the training materials are. But if you don't, it's an amazing resource filled with tutorials. Most of it is materials for scientists. Here's some application or scientific, workflow or set of tools. And here's how to use them within Galaxy. There's a lot of background about the science there, a lot of background about Galaxy. And lately, too, it's not just been for scientists. So it's also for developers and admins, a great set of resources there for these, for anyone using Galaxy. And these slides themselves are hosted there. It powers training.galaxyproject.org. So be sure to check out the content there. The project itself, the source code is written in Jekyll, static site generator written in Ruby. It has its own Gitter channel, training-material. So be sure to check that out. Communicate around that. We have a second static site code base, and it's Galaxy Project/Hub. It's the communication and documentation hub for basically all the rest of the Galaxy project. It's what powers galaxyproject.org. So you can check out the code base there. It's written in Metalsmith, I believe, at the moment, which is a node-based static site generator. So maybe you want to drive Galaxy via the API. So BioBlend would be a resource, or probably the primary resource to check out. It's written in Python, and it's the best set of documentation and usage examples for scripting the Galaxy API. So be sure to check that out. It's got a dedicated Gitter channel. There's some other resources in other languages for using the Galaxy API. Blend for PHP has been, I guess at this point it's a little, so I guess all three of these at this point are a little dated, right? And so that's why, even if you're not interested in using Python to script the Galaxy API, BioBlend might be a good resource for you to sort of check out how it goes. But these three projects are for PHP, Java, and Clojure, respectively, and they can at least give you some ideas about how to get started, even if they're sort of super actively maintained. Cloudman is another user-facing application. It manages a Galaxy Kubernetes cluster, and it's sort of what powers the appliances that get launched by Cloud Launch. It's written in Python. So check that out if you need a virtual cluster, or if you really want to get in the weeds of what's powering launch.usegalaxy.org. Another way to sort of drive Galaxy virtually, another virtual appliance that's sort of targeted at end users for Galaxy is Bjorn's Docker Galaxy Stable, sort of high quality Docker containers for Galaxy environments. Releases correspond essentially for each new version of Galaxy, and there are many flavors available. So there's proteomics, chemical toolbox, RNA workbench, etc. It's a good way. It's a good stable base to build custom Galaxy appliances from. And that's about the end of the user-facing things. The next section is for plugin developers. The most sort of common plugin developer for Galaxy is a tool developer, and so we'll talk a little bit about tool resources first. And when it comes to tools, the tools IUC is the place to go. It is a set of Galaxy tools maintained by the Intergalactic Utilities Commission. It's a variety of tools for many different application areas and sort of general purpose tools. And so it's a great place to find tools, but also it demonstrates the current best practices around tool development. It demonstrates how to develop tools on GitHub and then deploy them to the Toolshed. So it's a great resource, a very active community. Be sure to check it out if you're interested in tool development. There's some older tools that are still sort of important tools that appear on usegalaxy.org or usegalaxy.eu and that are developed by the same set of people, but they don't necessarily all follow the current best practices. So kind of legacy tools that are still important and sort of still maintained. There are many more tool repositories, though. The tool IUC is great, but there's other approaches and there's other application areas and there's other, there's a lot out there. Bjorn's repo is a big repository that's got a bunch of different application areas represented. If you're developing a particular workflow or scientific application, maybe you're wrapping a particular tool suite and you want a more focused repository that's not like Tools IUC that has many tools. Maybe you want a repository that's a set of high quality wrappers, for a single application. Peter Cox repos are a really good example of this. Like for instance, the Blast repo is a really nice set of wrappers around a particular tool suite, Blast. And so the repository itself, has a lot more documentation that's like tailored to the Blast application. So that's really nice. So this is, a different approach to tool development, but that's probably very useful for a lot of the people listening to this. Yeah, and code tools are available, BioPython. Galaxy Proteomics is another big repository. A lot of different proteomics specific tools in here. A good community of people are developing that. They've got their own Gitter channel. So be sure to check that out if you're interested in proteomics. Yeah, and there's more. Our more recent endeavor around, recreating that wonderful experience and community of the Intergalactic Utilities Commission is the Intergalactic Workflow Commission. We're trying to build a community around best practices and workflows and, specific scientific workflows and best practices around workflows, sort of like the IUC, trying to do both at once. There's a Gitter channel to get going with the conversation. We're hosting some best practice workflows, the source repositories, and best practices for publishing them to DocStore or our workflow hub. So be sure to check that process out if you're interested in publishing workflows. So those are repositories that host actual tools and workflows. Planemo is a nice application, a set of command line tools for developing tools and workflows. So they've got, Planemo has functionality for linting, testing, and deploying both tools and workflows. Sort of considered the best practice approach for Galaxy tool development. And then Planemo Machine is a virtualized environment for tool development. It's a recipe for building a Docker container, virtual images, etc. Much less used, probably much less likely to use Planemo Machine than Planemo, but linking to the resources that are available. A newer project that is really exciting is the Galaxy Project Language Server from David. So this is a runtime for interacting with Galaxy tools that Visual Studio can plug in, and there's a Visual Studio Code extension for tool development based on this. It's got test execution, code completion, best practice enforcement, and documentation tooltips for Galaxy tools. So be sure to check that out. That's an amazing new resource. The next two repositories are less interesting, but they're important. They're less likely to be things that you'll interact with, but they're important pieces of the ecosystem, so I'm going to mention them briefly. StarForge is a framework for building Python wheels. So when we started first using wheels in Galaxy, not a lot of projects were publishing them to PyPy. We still have dependencies that aren't published as wheels, and so we have a reproducible framework for getting those published and hosting those wheels, and that's called StarForge. And then CargoPort is provides like stable URLs and caching for application links, etc. It's basically our big backup system for a lot of the different pieces in the ecosystem, and it's an important layer for reproducibility. Both of these things, though, largely transparent. You likely won't need to interact with them as a plugin developer. This last section is for deployers and admins. We've got a sort of variety of Ansible components for deploying Galaxy. We've got both the recipes, and those are in the Ansible-star repositories, and then the playbooks that sort of assemble these recipes into useful sites or host descriptions. And so use Galaxy.org, use Galaxy.eu, etc. all use Ansible for basically all sort of deployment tasks. It's all documented and all available in an open fashion under these repositories. If you haven't used Ansible before, it's an advanced configuration management system. It doesn't require a host on this. It doesn't require a host application on the server that's being managed. So it's more lightweight than, for instance, Puppet or Chef in that capacity. And we have whole training resources around how to use these and how to customize them, etc. And those are all available on the training materials website under the admin section. Galaxy Project / Galaxy Helm is a Helm chart for deploying Galaxy. Under the hood, it's using a lot of those Ansible resources, but it's packaged together in a nice little application that you can just point Kubernetes Helm at. It's leveraged by Cloud Launch and CloudMan, but is also usable standalone. Galaxy Project Pulsar. This is a Python project. It's a distributed job execution engine for Galaxy. So a typical Galaxy job runner requires or assumes that all of the resources on the system are available in a globally sort of consistent file system across worker nodes, head node, etc. Pulsar sort of is there to eliminate that requirement. It can do staging of data, staging of tool scripts, staging of tool configuration stuff. It can run Galaxy jobs in Windows. It can act as its own queuing system or access existing cluster managers, DRMs. So this is a resource for deploying running Galaxy jobs in interesting ways. Two projects here are going to be tools for managing a running instance of Galaxy. The first of these is Ephemeris. It's a library and command line toolkit for managing Galaxy plugins. These include tools, index data, workflows, and it's a layer on top of BioBlend for building these things. It's both, like I said, it's a library, so it's written in Python. It's got its own Ephemeris. It's got its own Gitter channel. What else to say about it? Yeah, but it uses the API. Another set of command line utilities for helping Galaxy admins is called GXAdmin. Every time Helena or Nate decide they need to run some query in Galaxy or produce some report, etc., maybe manage files in a certain way, they add a utility to GXAdmin. So now there are, at this point, it must be hundreds, but at least dozens. They all have documentation. It's essentially a set of bash scripts that are well documented and well organized for managing Galaxy. So you might be wondering, why are there two separate toolkits for doing this? And I think the answer is a sort of different philosophies. Ephemeris is a pure Python project. It's designed to talk to the library, whereas GXAdmin talks to the database directly, reads Galaxy configuration files directly, etc. So it's more appropriate to run GXAdmin, beside the application on the same server as the application. Um, yeah, so check out both of those projects if you're, an administrator of Galaxy. Check out the Gitter project, the Gitter channel, the admin Gitter channel, just to, if you have any questions about either of them, really. Another interesting Galaxy project from an admin perspective is TIAS. This is a Django-based infrastructure for creating pools of users in Galaxy for training events and connecting them to the Galaxy instance. So this is basically used to power the EU training infrastructure. Yeah, it's got its own Gitter channel, so check that out. This is useful if you're wanting to build, I think, groups of users in Galaxy and treat them in certain ways. I mean, Galaxy can do some of that on its own. I mean, Galaxy has its own concepts of groups and quotas and stuff. But from an admin perspective, if you want to, there's certain things that TIAS can do, including a nice little sort of runtime view of what's going on with the training, what the jobs that are connected to the pool, etc. Those are the Galaxy project, the Galaxy specific projects I wanted to mention, and there are dozens, hundreds of other sort of interesting projects that are used by Galaxy. I mean, Galaxy has, dozens of open source dependencies. There are hundreds of Galaxy tools that are open source projects. But I did want to point out Conda and Biocontainers as special friends of Galaxy. They each have their own Gitter channel. They're each basically essential at this point for running best practice tools in best practice ways, either on machines directly or using containers. Check out additional training materials, tool dependencies in Conda, tool dependencies in containers, for more context around how Conda and biocontainers are used. All right, now let's think about putting this all together. Bjorn put together this nice slide. And the idea is there's these different, activities in the sort of research process and how different projects sort of can help you, do all of this within Galaxy and do good, high quality open science. So, you start in the realm of biology and you have a question, and maybe answering that question needs numerous tools. That's where development comes in. These are the underlying applications that you might want to wrap in Galaxy. And then we hit Bioconda, one of those friends of Galaxy projects. You want to build a package to wrap that tool up and make it portable, make it easy to run anywhere. Bioconda is very useful. It's a package manager that makes it very easy to do that. We have some infrastructure called MALD to build biocontainers, which sort of takes these recipes and automatically creates containers for them. And these things make deployment easier. Cargoport we use to sort of back up things in Bioconda. And so now we're getting into Galaxy projects, actual Galaxy projects. So you've got a recipe for running this tool and you want to wrap it in a Galaxy tool wrapper. Planemo is a great tool for that. You can wrap it, test it, link it, and then publish it to the toolshed with Planemo. And maybe you can orchestrate lots of these, as we're sort of getting into deployment here, orchestrate lots of these different tools together into a workflow, running on a Galaxy instance that's managed by Ansible. Maybe you want to use a flavored Galaxy instance, a local HPC server, or a cloud resource. Maybe you need Pulsar to run it on a remote system. This is all sort of falls in the deployment umbrella. We've got some resources for documentation. This slide's a little outdated, but the community hub, training materials, etc. So as you go from documentation to training, that's what you do there. Build tutorials. These tutorials, the scientific ones, all have dedicated input sets that we publish to Zenodo so that we have DOIs for all the training data. We've got infrastructure for helping you build Galaxy tools. And then you can support your training on Galaxy Help or on GitHub or Gitter. So that's an ecosystem, and it's not even the whole ecosystem. There's lots of other projects that are very useful that I just couldn't get to in the time I have. But the rest of this talk is going to focus on Galaxy Project slash Galaxy, the sort of core project that presumably you came here to learn about. And we'll start that with the next video. Thanks so much.